when OpenAI launched GPT 3.5, it was extremely, you could call it as a simple update in their research, right? So they had to show some update to investors because they were non-profit and they raised a bunch of monies, close to $1 billion. They were investing serious $1 billion on compute. Then they launched 3.5. People suddenly started realizing that it can able to generate text really well, really well, right? As good as a human and sometimes better than humans, at least in certain kind of problem statements. So this is the inflection of a new AI era, right? But the conclusion was you need large data, large model, and large compute. As long as you can scale all these three, you can solve a problem. This is demonstrated in text. This is demonstrated in protein structure. This is demonstrated in images. That's when it became like whoever wins the jackpot will become the winner of it. For example, so then people started investing heavily on building such large models, large data sets. Compute was invested like anything else. This is the search for NVIDIA demand going up, skyrocketing heavily in terms of building these kind of models, for example. So this is the new era for now the new era of large models. You can call it last decade was primarily perfecting the deep learning scale. Now we are applying that scale. So we are primarily applying that scale for from this year onwards, right? So there is a certain guarantee of predictions like an AGI, all of this, because now we know that this is a function of scale. But it's not without criticism for sure, right? Like Jan LeCun, for example, he's a very strict criticism around LLMs because these are next token prediction, right? Auto-regressive models which are predicting the next token. As I said, learning the token and predicting the next token, for example. But in reality, there is a limitation of how far you can achieve from these kind of models, right? Let's start with reasoning. You mentioned about prompting, for example. So typically what happens is you give an initiation to the LLM to generate the text. This is what your prompt or question, whatever it is. You are creating the first initial set of sequence and the model tries to complete the sequence, right? Now, there is a bunch of questions right now, right? Is there a reasoning while generating the sequence? Or is there a conscious while generating the sequence? These are the two big questions right now. And then the third question is around how is the model functioning to generate the sequence, the explainability part, right? Now, the way to generate the sequence properly is giving the prompt properly. One is, of course, I can increase the size of the model, but if my prompting is not good, then the model can always fail in giving that output. Now I have a trillion tokens kind of model, billions and billions of tokens the model is trained on. It becomes quite hard to be able to create the right prompt for your problem, right? This is where the reasoning came into play. Reasoning is how well I can draft the chain of thought. Chain of thought as in the sequence of prompts in a manner that I can make the model give the best in a very less resource intensive manner. This is one thought of school. Second thought of school is I will make the model think more and more and more before giving me the answer, such that I can utilize the humongous amount of learning that it has. But instead of restricting the output time to, let's say, 1 minute, I'll increase the output time. So this is the test train compute, right? Test train compute is instead of taking the inferencing at instance, I'll increase the output time. I'll make the model think more and more before giving me the answer, such that it can able to, or it should be able to solve more complex answers, right? So you have seen early prompt era in 2021, 2023. And then you have seen chain of thoughts in 2023. You're seeing reasoning in 2024, late 2024. Now you're seeing test and compute being scaled. Like if you used the capabilities like deep research, which now every LLM tool has, deep research is nothing but making a model think more and more and more during the inferencing time. such that I can able to solve that problem, right? So people have done experiments to prove that if I give, let's say, one full day, to think, what would model give me as an answer? Versus if I give you 1 minute, what would model give me as an answer? So for problem statement, something like, let's say, theorem proving, right? I want to prove a theorem, for example. If I can increase the compute, I can make the model prove the theorem. Uh, this is why reasoning models are getting increasingly better in solving the Olympiad level mathematical questions, because now it has more ability to reason, not think, reason and also time to think from that point of view to give you that answer. So there are two things happening. One is I'm increasing the scale of the model and I'm increasing the techniques around reasoning such that I can get the answer. But the question always comes is this the path to AGI, for example? So that's always the question that comes back to it.